So today for Math 3, we're going to skip around the unit a little bit because this topic is nice and short, so it fits in nicely before spring break. So what we're going to be doing is rewriting radical expressions. This is taking radicals and turning them into fractional exponents. Okay, so a couple things about these problems. A lot of this problem deals with the unseen, okay? If you have a square root here, the number in what's called the index is a 2. It's not written because it's automatically assumed it's a 2. The same way, if you don't have an exponent on either a number or a variable, it's automatically assumed it's a 1. Okay, so what you're going to do for these problems is the exponent becomes the numerator, and the radical number, the index, becomes the denominator. All right, and it makes a fractional exponent. All right, and the next example, again, this is 1 as an exponent. Okay, so the 1 is the numerator of your fractional exponent. The 3 for the cube root is the denominator of your fractional exponent. Okay, so if you have the 4th root of x squared, it'll be x to the 2 over 4. 2 is the exponent, which is the numerator. 4 is the root, which is your denominator. Now, technically you could reduce your fraction here, and you can get x to the 1/2. You don't have to reduce, but I do want to show you that it is possible because it might show up in other problems. All right, because we know that's the root already, I'm going to skip that part and go right to the end. So you have x, the exponent is your numerator, the root is your denominator. And there you go. So you're just rewriting a radical as a fractional exponent. So let's look at some examples here. Okay, because there is no number in the index on what kind of root this is, it's automatically a 2. So you'll have x to the 2nd over 2. So now, again, you can reduce this. 2 over 2 is just 1, so this could just equal x. Right? You don't have to reduce, but I do want to, again, show you that it's possible. Here, the square root of 4x squared, or 4x to the 6th, rather, sorry. So you have 4 to the 1/2, because the exponent on the 4 is a 1. And then x to the 6 over 2. Again, I'm going to show you that you can reduce this, so it's 4 to the 1/2, and x to the 3rd. Okay, if you don't reduce it, that's fine. If you do reduce it, that's also fine. Okay, this is x to the 8 over 4. I'm not going to reduce that one. I'm going to stop reducing in general. Here, now for this one's a little tricky because the -8 has to go with the, it has to go together, and it has to be in parentheses. So you have -8 to the 1st over 3, so the 1/3 power, x to the 4/3, and y to the 3 over 3. (18), so you have 18 to the 1/2, x to the 10 over 2. And here, you have 64 to the 1/3, x to the 5/3, y to the 7/3. Okay, so that is taking radicals and putting them as fractional exponents. Now we want you to show the other ways as well. So if you were given a fractional exponent, how do you make it into a radical? Okay, the same thing applies just to reverse. Okay, the numerator is your power, your exponent, and the denominator is your radical. Okay, so you're just going to go reverse. Okay, so the exponent is 1, the root is 2. Now for this particular problem, because we don't write either the 1 or the 2, you don't need to write them down because it's just assumed that's a square root, x to the 1st. Okay, you have x to the 1/3, 3rd is the root, x to the 1st power. You don't need to write the 1 on the x. Okay, here it's the same thing, cube root of x to the 5th. Here I'm going to skip this one because you don't actually need to do that little mini piece. You have x to the 7th to the 4th power, or to the 4th root. And there you go. So you're just working backwards. So let's look at some examples. Okay, you're looking at your denominator, so you're not going to make all these separate things, each one a separate radical. You're going to look at your denominator to find out what your root is. So it's a fourth root. Okay, and then you're going to look at your numerator to find out what the powers are, the exponents are, and all the terms. So we have 16 to the first. I don't need to write down the 1. X to the 6th. Y to the 8th. And that's it. Here I'm looking at the denominators to find out what kind of radical I have. I have all 2, so I'm just going to put the square roots. I don't need to put a number out in front because it's just assumed it's a 2. I have 36, don't need to write the 1 as an exponent. A to the 4, B to the 3rd, C to the 10th. Again, they're all 2's, which means I have a square root. X to the 3rd, Y to the 4th, Z to the 9th. I put these in there because they're a little bit trickier, because now we have a 2, a 4, a 2, and a 4. So something's off, okay? But what this means is that something was reduced, okay? So we need to go to the highest common number. So 2 can be a 4. So what that means is if this was reduced and these were 4 and 4 as our denominators, we have to multiply the numerators by 2 as well, because we multiplied 2 by 2 to get 4. So I have that by 2 and this one by 2. Okay, which gives me the 4th root of 17 squared, x to the 3rd, y to the 6th, because again I multiplied 2 times 3, and let's extend that a little bit, z to the 1st. I don't need to write the 1. Okay, so they all have to have a common radical to work under. So that might mean you have to change the denominators because you reduce those, because somebody reduced those fractions. Okay, that's why reducing fractions can be a little bit tricky. All right, here you have 2 common denominators, so that means you're going to have a square root of 24 a to the 5th, and lastly we have 3 and something to the 2nd power. Okay, so again, this was reduced. The denominator over 2 is 1. To make it look like 3, we had to multiply by 3 on the top and the bottom. Okay, so that means I'll have 3 as my denominator. So I'll have a cube root. All right, 64 already had a 3 on the bottom, so its exponent is 1, which I don't need to write down. X has a 3 as its denominator, so that means I'm going to put a 4 there. But y did not, so I multiplied by a 3 on the top and the bottom, which gives me y to the 6th. Okay, now again, we're not often going to show you the reduced versions just for the sake of time and effort for this unit on our shortened year, basically. So that's converting radicals to fractional exponents and back. All right, try the practice, ask questions if you need help, and